are doing this, yeah, then we have done the Rutherford atomic model. Rutherford atomic model, what he is saying, once again quick see, atom is spherical in shape, the entire mass of the atom is concentrated at the center part of the atom called nucleus. Nucleus consists of protons and neutrons, and electrons are revolving around the nucleus like planets revolve around the sun. So therefore this model is also known as planetary model. Next, come to the concluded drawbacks. There are two drawbacks. Number one, he said that electrons revolve in spiral orbits and finally it will be losing energy and finally it falls into the nucleus and nucleus will collapse. But it is found in the nature that they are stable. Next one is what? The second drawback, he says that a hydrogen atom has a, it is a continuous spectrum, but it is no more a continuous spectrum, it is a line spectrum. We have in spectrum classification, that I will tell you now. What is spectrum? In spectrum classification. See, just to understand a spectroscopy, okay, let me just write the classification. I will tell you what exactly it is, because the student don't know what is a spectrum, what is a class, how does it happen. See, spectrum, we have a discontinuous spectrum and continuous spectrum. Again, there is a class of absorption spectrum, emission spectrum, that I will tell you that later on. Continuous and discontinuous spectrum. Now, in discontinuous spectrum, we have two. That is, one is line spectrum, one is band spectrum. Okay, line and band spectrum. Now, we have continuous spectrum, discontinuous. Continuous spectrum is rainbow is the best example. Means you cannot exactly tell where the first color ends and the second color will start. That is a continuous spectrum. Discontinuous, we have line and band. Line means sharp lines will be there. Band means thick bands will be there on the spectrum. What is a spectrum again? For this to understand, again in spectrum we have we have absorption spectrum and emission spectrum. Absorption spectrum and emission spectrum. Okay, this is there in chemistry, grade 11 chemistry first term. Grade 11 chemistry first term. This was to be explained there. Absorption and emission spectrum means, absorption means what? I am giving some light, maybe I am giving a white color light to the sample. It absorbs few and remaining it will release. It absorbs few and remaining it will release. That happens in the absorption. In emission, when you give white color light, white color has seven different colors, components. So what it will do? It will emit. It will emit. Instead of taking it, starts emitting it will only take the energy and remaining, it will emit the colors. Understood? That happens in the emission spectrum. So, example, our tube light, is it an absorption spectrum or emission spectrum?
Emission.
Very good. Emission.
It emits light.
Emits light. That is our tube light is the best example. Now, what exactly is happening? How to study the spectroscopy? For any spectroscopy, we need only three things. One is source, sample, and detector. Source, sample, and detector. I'll start rightly from here. Source. Simple example, X-ray. In X-ray, the source of when you take an X-ray, the source of X-ray, which are emitting radioactive, the rays, X-rays are coming out of a Coolidge tube. Sample means you are the sample. You people are the sample. Detector means your photographic plate or the detector. The photographic plate is a detector. Go to MRI, you are the sample. Source is the high frequency magnetic rays, and detector is the photographic plate again, which is mounted inside the circular shape. So everywhere in that plate, that one thin sheet will be there. Yeah. Inside there is a photographic plate, but now it is digital. Okay. Earlier there used to be like this photographic plate like this.
It used to be like a photo.
It used to be like this. Photographic plate like this. Yeah. Understood? But now we don't have now we are not using that one. We are using inside there is a digital one which captures. We have analyzer actually. Okay. That is like an analyzer.
Just like that phone.
Like a phone. It will take capture and that is connected to the computer and computer will give the print. Yes. It's long like that. So earlier what we have to do after taking we used to inside that we'll put one photographic plate. Once it gets exposed, we have to develop that one. Yeah. We used to take it to the dark room and develop it. Yeah. Then it will become negative. Understood? In red color light or a dark room, we used to do this experiment. We used to pour it into the chemical, then really remove it, finish. Dry it off, it will become a negative.
So they also use this grit paper, right?
Yeah, that is a grit paper only for this MRI and PT scan and all. We use grit paper.
It has some kind of each color can be put in.
For that only we get a colorful pattern. That's the reason. Okay, anyways, we are not going into depth, but To understand spectroscopy, we only need three things: source, sample, detector. Whether you go for X-ray, whether you go blood test, anywhere. Again, spectroscopy in blood test, how it is? Your blood is the sample.
Yeah.
Your source is the machine.
Centrifugation.
Detector is computer now.
Right?
Yeah, centrifugation.
Centrifugation.
Like suppose you put the in test tube, you put it.
Yeah,
The centrifuge, that is the source.
the higher atoms will go further and the
So, but how do they do spectroscopy for planets as well? Like NASA does spectroscopy for planets.
That is from the with the light reflected from there. Sunlight hits the planet, it will reflect back, right?
Then won't that light takes time to travel, right? So won't that be like an older version of the planet?
That's what I'm saying. So the light, the star which you see tonight is the light reflected from the star to 4 years, 3 months back. When you were in grade 7 or grade 8, that has emitted, and you are refusing me tonight. Got it now?
Okay.
So don't think about the galaxies and all.
massive.
Time travel is possible.
You understood now?
Yeah.
Is it clear? Okay, quickly, we'll go to the next one.
Massive.
That's Bohr's model now. Is it clear, guys? All of you? Here. Sayan, Sayam, Joshua, Juan. You can have your food while eating your food. You can listen to the class.
So we'll also order?
No problem. You can also have your food.
They will take proper break.
Yes, sir. Like we'll order.
You want
now.
to
It will
have
take-
you want landline number?
So it's an online.
Online.
Oh.
So we'll order it now. It will come in half an hour. So
Okay.
at 3 o'clock we can have break.
No problem. No problem. Anytime you can have the food.
So you will also have the break.
So we'll order for you also, sir.
Yeah. We'll order
You
around.
first have your food.
You already
sir.
had it.
No, I did not have it.
Yes,
So
so
then
we
it's fine, so then we
you eat with us. You can save that food for the night. Or else at night also you have this.
This guy, you know.
So you just stay here only, sir.
So before we used to go to tuition, right? Morning we'll go to tuition class, evening we'll come out.
There with me also they were like that. It was like that. I used to have batches before.
So I used to have batches, but batches will go after 2 hours or 3 hours.
No, they used to be
Yeah,
at
we
my
should go
home.
morning, come back at night.
They used to
Yeah,
come
yeah.
morning and they used to be till night like that. But now, because of my schedule like that, I am not able to do it.
Except for a job for 4 months, we don't write our boards.
Yes, you know. Sajid, throw this fellow outside. Now, Board's model. According to Board's model, first used to be very quiet. Huh? Now, see.
So I was quite in 9th and 10th grade.
Okay. N equal to 1 equal to K. N equal to 2 equal to K L. N equal to 3 equal to M. And next one is N equal to 4 equal to M. Okay. So Niels Bohr is the student of Rutherford. Lord Rutherford, he himself got the Nobel Prize and he had 3 students, and all the 3 students also got a Nobel Prize. So one of the eminent scientists of physics and chemistry both. So Rutherford, he according to Bohr's model, Niels Bohr, he said that what happened?
The passwords are working.
Password everywhere. From the phone you can't do.
So it's like it's
very
tiny.
small, though. So we can't choose.
Yeah, you can.
So you eat only mutton or you eat chicken as well, sir?
So what do you want to have?
No, whatever you're having, just.
No, sir, we will have proper, sir. It's fine. Since you don't feel shy, sir.
No, I won't try for
Yes,
food or not.
so I will have fish. He will.
Sir, I will have anything you have, sir.
Yeah, I will have fish.
You said only one, no? In one they are giving.
So it's very cheap, sir. So we order 3-4 dishes. It's like fancy but very affordable. It's very fancy but very less. So what do you want to have? Mutton?
What are you ordering for?
I'm ordering fish.
What about this guy?
So he will have whatever you.
Yes, ma'am. We are going ahead now. See here, Bohr's model. According to Bohr, he said that atom is spherical in shape. The first one. He started with the first one. He said that atom is spherical in shape. Okay. Atom is spherical in shape. The second one is the entire mass of the atom. He copied the postulates of Rutherford, and he said that The entire mass of the atom is concentrated in the center part of the atom called nucleus. Nucleus consists of protons and neutrons. Electrons are revolving in particular orbits. Electrons are revolving in particular orbits. Okay. So as the size of the orbit increases, energy associated with the orbit also increases. As the size of the orbit increases, energy associated with the orbit also increases. This particular orbit are named as stationary orbits. Okay. So third one, when an electron jumps from lower level, suppose when it absorbs energy, like when an electron, suppose this is EI and this is EF. When an electron absorbs energy of h nu, so what will happen? It will jump to the higher energy level. It gains the energy and it will jump to the higher energy level. So how it is calculated? Delta E is equal to what? EF minus EI. EF minus EI, which is equal to h nu. The fourth one, when an electron jumps from higher energy level to lower energy level, it releases energy in the form of light. That is what this is h nu. So delta E is equal to what? EF minus EI, which is equal to h nu. Is it clear? EF minus EI, which is equal to h nu. So this is about what we call. Is it clear, all of you? Yes, ma'am. See, once again, atom is spherical in shape. The entire mass of the atom is concentrated in the center part of the atom called nucleus. Nucleus consists of protons and neutrons. Electrons are revolving around the nucleus in particular orbits or stationary orbits. As the size of the orbit increases, energy associated with the orbit also increases. And now, when an electron absorbs energy, it will gain the energy and it will jump to the higher level. Now, how to calculate that? Delta E is equal to EF minus EI, which is equal to h nu, where h is Planck's constant and nu is the frequency of incident radiation. Now what happens is when an electron jumps from the higher level to lower level, it releases energy in the form of light. How much it is that? Delta is equal to EF minus EI, which is again equal to h nu. Okay. So, and also he tells about the angular momentum. When an electron is revolving around the nucleus, it is in circular motion. Yeah, circular motion means it is having angular momentum. What is the formula for angular momentum? Moment of momentum. Definition is moment of momentum. Moment means torque. Moment of momentum is angular momentum. Moment of momentum is angular momentum. So what is the formula? L is equal to R cross P. We also write L equal to MVR. MVR is equal to NH by 2 pi. He says that is equal to NH by 2 pi. N is what? The principal quantum number. He gave the concept of N. N means principal quantum number. From here only we got the concept of chemistry. That N is principal quantum number. 1 is first orbit, 2 is second orbit, 3 is third orbit, 4 is fourth orbit. It goes in that way. KLMN. Is that clear? This is one of the postulates of Rutherford model. Sorry, Bohr's model. So he gave 3 postulates. In the textbook there are only 3. Number 1, when an electron revolves around the nucleus, it has angular momentum. Angular momentum is given by MVR is equal to NH by 2 pi. Second postulate, he says that when an electron gains energy, it will jump from lower level to higher level, or when it is jumping from higher to lower, it releases energy in the form of light. The third one is as long as the electron is revolving in the same orbit, it neither gains energy nor loses energy. As long as the electron is revolving in the same orbit, it neither gains energy nor loses
Because
energy.
it's neutral, right? Like the centrifugal and the
It balances each other. That's the reason. Is that clear, all of you? Yes, sir. Could you repeat the second postulate? Second postulate, he says that once again, atom is spherical in shape. The entire mass of the atom is concentrated at the center part of the atom called nucleus. Nucleus consists of protons and neutrons. Electrons are revolving around the nucleus in particular orbits. Means as the size of the orbit increases, energy associated with the orbit also increases gradually. Understood? Is that clear, all of you? Sayam, Zion, Johan and Joshua. Is it clear?
Yes, sir.
Okay, good. So we'll go to the next one. That is, he gave 2 derivations. One is to calculate the energy of the orbit. Okay, energy of the electron in the orbit. Number 1. Number 2, he tells about what is the radius of the orbit, velocity of the electron in the orbit, and third one is energy of the orbit. Okay, kinetic energy of the electron in the orbit. These 3 we will calculate now quickly. Okay, then we'll go to the next problem, next concept, that is about the hydrogen atom spectrum. Okay, now 1 second. Now, just order for yourself, man.
No, sir, it's fine, sir. Still, sir.
Now, here we have, we'll calculate the energy, okay. First we'll calculate the energy, then we'll electron orbits, okay. Ask me please, do ask me in between, okay, if you're not clear with anything. Now, please take the screenshots there and there itself, okay. Otherwise, anyways, video I will send. Now, the next one is electron orbits. Electron orbits. So what will happen here? See, this is the nucleus. These are the orbits. Okay, so
what is it? Name?
Sama 2, 102. Let's say MA, space 2. Landmark you can take Cross Supermarket. RAZ. Okay. Now, so what is happening? You know, when an electron is revolving in the orbit, it has when an electron is revolving in the orbit, it has two forces. So it's balanced with the two forces. One is centripetal force, Fc. So Fc equal to Fe, electrostatic force. C for Coulombic force. C for Coulombic force. Sorry, the E for Coulombic force and C for centripetal force. C for centripetal force. Okay. C for centripetal force, E for Coulombic force. So we have, what is the formula? We have the formula 1 by 4 pi epsilon 0 into Q1 Q2 by R square. This is the formula. And the other formula is MV what is that? MV square by R. This is the formula. Now here, instead of, suppose if it is a hydrogen atom, think that there will be only one proton and one neutron. If it is hydrogen atom, there will be only one proton and one electron, and one proton, and okay, one electron and one proton. So in that case, I can write 1 by 4 pi epsilon 0 into E square by R square, which is equal to MV square by R. Now here R and R will go away. So I want to find out V square. V square is equal to how much now? The value of V square will be, or the value of R will be how much? R will be equal to E square by 4 pi epsilon 0 into MV square. Okay, this is the value of R square. Now, or if I want to write V square value also, I can write here. So I'll write here, this is V square and this is R. So kinetic energy formula is what? Half mv square. So that will become equal to how much? Half into m into v square. What is v square? E square by 4 pi epsilon 0 into mr. This is the value of kinetic energy. Okay, this is the value of kinetic energy. Is there anything to cancel here? Yeah. We can cancel m and n. So we'll get kinetic energy equal to how much? E square by 8 pi epsilon 0 r. This is the value of kinetic energy. Okay.
Yes.
Now potential energy equal to how much? Potential energy is equal to the same potential energy which we studied in electrostatics. What is the formula there? Q1 Q2 by 4 pi epsilon 0 r. This is from electrostatics chapter or capacitance chapter. Is that clear? Kinetic energy of electron is what? Half mv square. This is v square value. V square value is substitute. This is not v. We are not going to square it again. V square value is there here. So that substitute as it is. Don't square it again. So e square by how much? 8 pi epsilon 0 r. M and m will get cancelled. Understood? Is that clear, sir? Joshua? Chalo. We'll go to the next one. Potential energy is, this is from capacitance chapter. Potential energy. Okay, so Q1 Q2 by 4 pi epsilon 0 r. So here instead of writing Q1 Q2, I'm writing E square by 4 pi epsilon 0 r. Now what will happen? Let it be equation number 1 and let it be equation number 2. So total energy is what? Generally this is written as K, and generally it is written as U. So total energy is equal to how much? Total energy is potential energy plus kinetic energy. So we also write implies E is equal to U plus K. So E is equal to how much? U is U plus K. E square by 4 pi epsilon 0 R plus E square by 8 pi epsilon 0 R. So when you take common, so you will get what? E square by you will get, one is minus, this is minus, okay, this is minus, so you will get here minus and this is plus. So answer will be E square by E square minus E square by 8 pi epsilon 0. Why there is attract? Because there is attraction force. Why potential energy is negative? Because there is an attractive force. Not between electron and proton there is an attractive force. If one is positive, the other is negative. That is the reason I got minus E square. Is that clear? Is it clear, sir? Zayan and Sayam, Joshua, is this clear? Okay, quickly, will you note down or just take a screenshot of this one? It's up to you. Is this clear? This is the energy of the.
So this is the you told that day.
On that day explain.
K is equal to half mv square.
Yeah, half in this.
And then we get it like
Substitute the value. We substitute this value. Is this clear, all of you?
This is we are finding the force like electrons.
Starting with the Coulombic force equal to electrostatic force.
force.
Clear, sir? I don't know.
They are sleeping, so you want to
Sayam.
sit here.
Sayam, Joan, sorry. Yeah, Joan and Zayan.
Yes, sir.
Yes, sir.
Zayan, are you there?
Sir,
What, sir? Don't sleep. Okay. Had your food?
I'm eating.
That's I'm asking you. Had your food?
No, sir.
Why? Why are you hungry? You can have your food and listen to the class.
Sir, I'm eating it.
Huh?
Nicely.
Simultaneously, you can do no. Just listen to the class. No need to write. Just take the screenshots. Okay. Later on, you can write copy. Okay. Shall I go to the next topic then? To find out the radius and all. Can I go to the next one? Radius, velocity, and energy. These three things I have to do now. Energy of the orbit. Tomorrow, what time I have to take class, man? Please tell me now itself. 9 to 11 I am busy.
So 1:30
9 to 11 and up to 12 I am busy. Yeah. 9 to
So 1:30 will come
3
here.
classes. Yeah.
1:30 will come here. We'll stay till night.
1:30 you will come. 1:30 is that okay tomorrow? Sayam.
Sir, I can also come on site.
Yeah, no problem. You can come. Do you want to come 1:30? 1:30 is that okay? I'm asking the timing.
Yes, sir. Yes, sir.
1:30 is it okay? Zayan.
Bankrupting them.
Zayan, Joshua.
So much less.
Joshua is okay.
No, no.
Joan is okay. Zayan, 1:30 okay.
40.
I'm not able to hear anything. Yes or no? Okay. 1:30. Okay. Now fix the time 1:30 to 3:30 tomorrow also. It will be 2 hours tomorrow, 2 hours on Sunday also. Okay, same timing. Same timing is okay, man. Sunday. Hey. Sunday also 1:30 is okay?
Yeah, sure.
So every day what to do?
No. Bring the lunch tomorrow. Okay, I'll ask to tell your parents. Okay.
So why, sir?
Why you want to waste your parents' money?
Sir, it's my money, sir.
Oh, my money.
So he did internship here and about 4,000 dirhams.
What internship he did?
So I worked at Dubai Astronomy Group.
What is it? Astronomy group.
Dubai Astronomy Group.
So what you did there?
So we build rockets and we build a spectroscope.
Okay.
That's why I asked that day I asked you about an online about spectroscopy, the first, like I think third class last year.
I don't remember. Anyways.
So he has money, sir. Bank account also.
No.
Nice money.
Okay, next one. Wait, I have to do the radius part now. So I'm starting with the, see, I have to find out radius of the orbit The first derivation. Second one is velocity of electron in the orbit, and third one is energy of the orbit. Energy of the orbit. These three things we are going to solve. Energy of the orbit. Okay.
So we ordered 4 roti for you. That's fine, right?
I don't need that much, man.
So it's fine. So like now you need to move it.
Okay.
So with this,
If I eat too much, then I will sleep then.
No teachers here.
Then.
After that, we'll learn nicely till night.
Okay. Now these are three derivations here. One is radius, one is velocity, the third one is the energy of the electron. So I'm starting with the when an electron revolves around the nucleus. Okay. So there are two forces here. Fc equal to Fe. Centripetal force is equal to Coulombic force or electrostatic force. So I'm starting with 1 by 4 pi epsilon 0. I'm taking again hydrogen model for simplicity. Hydrogen model. So E square by R square, which is equal to what? mv square by r. Okay, then r and r will get cancelled. I want r now. So r will be how much now? R or vn. We can also calculate r. We can also calculate vn. So velocity of electron in the nth orbit. So how much it is now? Here I am writing rn now. Instead of here I will write radius of rn. I am writing this. I am writing as vn, and this I am writing as en. Nth orbit. Now general formula. We are going to derive the generalized formula. Radius of the electron in nth orbit, velocity of electron in nth orbit, and energy of the electron in the nth orbit. Okay, energy of the electron in the nth orbit. So first we will start with the we'll start with this. So here we are writing suffix as n for nth orbit. Okay, now we'll start with the radius. Rn is equal to how much? Rn is equal to E square by 4 pi epsilon 0 into m into Vn. So what is the formula here? We have L is equal to MVR. MVR is equal to NH by 2 pi. Is that okay? MVR is equal to NH by. Now I'm writing here. I'm writing here M into V is equal to what? M into V is equal to, I want to calculate what? I want to calculate the Rn value.
so mv is equal to n.
So should I go with the next one? I will do one thing here. Wait. I'll take like this. Vn I will take here Vn square, which is equal to Rn. Okay? The same. Now what is Vn now? Vn is equal to E by under root of 4 pi epsilon 0 into Mr. M into Rn. Okay? Is that okay?
So you can take 4 outside there, 2.
Yeah, that okay. Now for timing let it be like that. So MV is equal to what? M into R is equal to what? NH by 2 pi M into R is equal to what? NH by 2 pi V. So we will substitute here. So Vn is equal to how much? E by 4 pi epsilon 0. Mr is NH by 2 pi into V. Or can we square it better? It will be easy for us, I think.
What is it?
Can we square it? Can we substitute directly in that equation? I think that will be easy for us.
Yes.
So Vn is equal Vn square will be equal to what? E square by 4 pi epsilon 0. What is Mr? Mr is NH by 2 pi into V. So what will happen now? This pi and pi will get cancelled 2 and this will become 2. Okay. So what will happen now? This will go like this. So Vn square. This is Vn now. So which is equal to E square into Vn divided by 2 epsilon 0 into n into h. Okay. So can we cancel this and this?
Yes, sir.
Yeah,
We can cancel. So what do we get now?
Vn
Vn is equal to how much? Vn is equal to E square by 2 epsilon 0 into n into h. Okay. So this is the velocity of the nth orbit. This is the velocity of the electron in the nth orbit. So similarly, we can also calculate the velocity of electron in the nth orbit. Similarly, we can calculate the radius of the nth orbit. How do we calculate radius? Very simple here. Just take here Rn is equal to what? Rn is equal to cross multiply. Rn is equal to what? E square by 4 pi epsilon 0 into mvn square, right? Mvn square. Is it clear? Now I'll substitute this value here. I'll substitute this value here. So, okay, I will. Is that okay?
Yes, sir.
That's okay.
Now, yes, all of you. Sir, N is the orbit. Yeah, N is the orbit. Which orbit it is? We are trying to find out a general formula. Is that clear?
Yeah, we can substitute and find out the answer.
Answers. Very good. So, yeah.
That's the thing, man.
Sir taught backwards and that's what he tells.
Yeah, that's what I said. Very good. Okay. So you understood.
FC
Now I'll substitute that Rn is equal to E square by, we substitute 4 pi epsilon 0 into m into Vn square. Is it Vn square? Yeah, it is Vn.
That's correct, sir.
It's correct only? Yeah. So this will En square means you have to power, no? E power 4 divided by 4 epsilon 0 square into n square h square. So this and this will become square. 4 and 4 will go away. Then epsilon and this one epsilon will go away. So what you are remaining with now? Rn is equal to how much? This will go up. Epsilon 0 n square h square by pi m e square. Is that the same?
Yes, sir.
Yeah. H square epsilon 0 into n square by pi. If n is equal to 1, suppose. If n is equal to 1, what do we get? R1. That will become epsilon 0 h square by pi m e square. So this is also said to be A0. This value is also said to be A0. So A0 means first radius of value of the first radius, because all are constants. Epsilon 0 is constant, h square is constant, pi is constant, m is constant, charge of electron is constant. So they found out, what they found out when you substituted all the values, it became 5.29 into 10 to the power of minus 11 meter. This they will not give in the exam. A0 value they are not going to give in the exam. So
Yeah.
A0 is the,
You have to learn
just
it before.
see what I'm saying is, if you want to find out the radius of the second orbit, don't do anything. Just multiply 2 into this value, finish. If you want to find out the value of the third orbit, multiply 3 into this value, finish, you will get the answer. Understood? So this is the value. So this is m. Is that clear? Oh, you joined from there. Okay. The down
You
part.
can't see the down
Okay.
part also.
Is it clear now, all of you?
Yes.
Please quickly copy this one or take a photo, screenshot. Then we'll go to the next one. Is it clear, all of you? I have to go for the energy last one. First, you see once again from the beginning. When an electron is revolving around the nucleus, and I'm taking hydrogen atoms because it is a simple one to understand. One electron, one proton. Because hydrogen has one H1, one electron, one proton, no neutrons. So this is very simple to understand.
Yeah, sure.
So Fc is equal to Fe. So the formula is got 1 by 4 pi epsilon 0 into Q1 Q2 by R square. Instead of taking Q1 Q2, we are taking E square by Rn square. Rn is a general formula. Radius of the nth orbit. Mv square by R. Just cross multiply, you will get this one. And in the place of MVR is equal to n/2 by 2 pi. Just modify that and substitute here. You will get this value. After that, what you will get now? Once you get this, you will get this value. After that, we have Rn. What is Rn value? Rn value is just cross multiply. You will get
Cross
this.
multiply and
Simplify this one also. Okay. And simplify further, you will get this.
Yeah.
Okay. And
then you have to
take n is equal to 1, you will get the radius of the first orbit. Is it clear, all of you?
plus n is equal to 1.
Zayan, Sayam, Joan, Joshua.
So what is A naught?
A0 is the radius of the first orbit. First orbit.
So they found that.
Just substitute, no? The
Yeah,
values.
yeah.
They're all constants.
Yes.
Epsilon 0 is constant, Planck's constant, pi is constant, m is constant,
Yeah.
mass of electron, charge of electron, just
So,
substitute.
sir, we take radius.
Sir, if everything is constant, then what do you find?
No. For the first orbit we found out. If you
Yeah.
want to find out second one, just multiply this value with 2.
Multiplied by 2. The entire thing multiplied by 2.
The whole 5.29 into 10 to the power minus 7. Just multiply by 2, finish.
They take radius from the center of the proton or
From the center of the nucleus to the
center of the nucleus.
nucleus to the
To the
orbit,
line of
whatever
the-
it is.
yeah,
That means the
orbit.
radius of the second orbit is exactly twice of that of the first orbit.
It cannot be. Yeah, twice. Yeah.
Twice exactly.
Yeah, exactly.
I mean, big atom level.
That's what I said. No, atom is very. Most of the atom is empty. That is the conclusion we got now. So if you want to understand the atom, it's like, football in the football ground.
Yeah.
Football is the nucleus and football ground is the atom. That much big is that atom. So that is why he concluded in that way, both of them. If you have an idea of a football and football ground,
Yes, sir.
football is the nucleus.
Nucleus, and the ground is the atom.
Atom, understood now.
And dirt is the electron. Yeah, that's
No
it.
fans, the audience.
Yeah.
Audience
They
there.
are
Maybe
going-
the, you
Yeah.
can say. The dirt or the grass, you
Yeah,
can say.
they are the electrons.
That they are the electron. That's so small.
Yeah.
Is it clear, all of you? Done, sir.
Alright, so
Did you take the screenshot of this? Then I'll go to the energy. I'll go to the energy now. Okay. Now, so energy of the nth orbit now. So I want what? I want the energy. Energy means energy, kinetic energy. So En is equal to, just substituting in the formula he said, no? Just 1 second. Substituting 12.4.
Confidence breaks.
1 second. Let me finish off this, then I'll take. Yeah, go. The slippers are there inside? Come on. Wait, 1 second. 1 second. I'll. I'm not using that. I have to put one mat out. Yes. You can pick that inside. Many things are in the cartoon and all. That's why I have to remove it. Okay, now. Yeah. Okay, going ahead with the energy now. 1 second.
So, half an hour for the class to get over. It's almost 3.
It's 3, no? 3:30, yeah. After that, you can have food. No problem. So, what about you? Just let me find out. Joshua, are you done with the exams? Joshua, are you done with the pre-board exams? No. Which exam? What are the exams left now? What are the exams left, sir? It is up to till 14. 14 means today is 25. It just started, you mean? And what about you, Juan? And Zayan? Sayam, you are done with the exams, right? I think one exam is left. They postponed some exams. Okay. What about you, Zayan?
The exams are on Monday.
Many people are not writing the test also, man. If you don't write the test, how will I come to know the status, whether you're understanding or not? Only chapter wise I am keeping that also. Electromagnetic waves I will correct today. We'll get over on 3rd. Okay. Anyways, now you write the exams. Okay, I will not disturb you now. I will not disturb you now. But after that you have to write the exams. Okay, submit all the papers separately. I will again send. Okay, now I am going ahead with the energy. So when we calculated energy formula in the previous derivation, it was E is equal to, we calculated that is E is equal to U plus K. Okay, U equal to E plus K. I'll just put that. E is equal to U plus K. So therefore, there I got E is equal to how much? E is equal to minus E square by 8 pi epsilon 0 r. Okay, so what I got here? Now when I substituted this value, minus E square by 8 pi epsilon 0, what is R? R value is there here. Epsilon, what is that? Rn value is epsilon 0 n square h square by 8 pi